Yes, hello. So, as Nels said, my name is Jacob, and today we're going to talk a bit about esoteric programming languages. So, the first question most people would ask is, what is an esoteric programming language? And in short, it's a language that someone who has too much time on their hands has eventually written at some point. It typically follows some kind of theme. It's often quite hard to use, and it always caters to a very select group of people. So there's a site called esolangs.org that contains a lot more information about this specific subject. So is there anyone in here who has actually who know any esoteric programming languages? One person out there? Sorry? Java, right. All right. And I take it that no one has actually worked with an esoteric programming language before? Ruby doesn't count? No? All right. JavaScript. All right. So you'll be a lot wiser about this once we're done with this. So why do people create these languages in the first place? So there are a number of different reasons. Typical reasons are to, if you have this strange idea that you want to try out and just see how it works. Often you just want to challenge yourself. Often you want to challenge other people. And often you just want to make some kind of stupid or elaborate kind of joke. That happens quite often. Typical reasons not to make an esoteric programming language, that is if you're going to use it for anything useful here. This is the point where I make a brief disclaimer. My interest in this is purely academic. Please do not hire me to write anything in any of the languages that you're about to see. So the first language that was called an esoteric programming language was designed in 1972 and it's called Intercal, which is short for the compiler language with no pronounceable acronym. So this was basically a parody language that was based on the languages that people were actually using at that point, Fortran, COBOL, and assembly. And as I said, it was designed back in the beginning of the 70s. So what we're going to do here is to take a look at 10 other languages that are, some of them are a lot newer, some of them not so much newer, but there are different reasons for looking into these languages. Some of them are just downright plain silly, other of them are actually very, very creative. There are myriads of these programming languages that exist today. If you look at esolangs.org, there's a long, long, long list of all these languages. Pretty much all of them are pretty much unknown, but some of them are interesting, insane enough to have reached an audience that is a little bit broader than nothing, basically. And I'm going to show you some of the biggest ones, some of the most interesting ones, and some of the silliest ones. And again, some of these are just downright silly. Other of them are interesting because they show the creativity that people have had when doing this stuff. And even though none of the stuff that I'm going to talk about today is going to be immediately useful for you, then you might have some interesting ideas being set into motion by seeing some of the ideas that other people have put into some actual programming languages here. Any questions so far? All right. So the first one is called ArnoldC. So this is one of the silly category languages. So basically it's a simple version of C, but every single command has been replaced with a one-liner from an Arnold Schwarzenegger movie. So the author's motivation in his own words is, although the one-liners of Arnold Schwarzenegger are fairly well known to the true semantics of the uttering, is yet to be understood. This project tries to discover new meanings from the Arnold movies with the mean of computer science. And one of the main things that people want this language to accomplish is for Arnold to actually see that it exists. It's about 3 years old. So some of the example commands that are available for you in ArnoldC are at your disposal here. I'll let you peruse them for a brief moment. And here is a hello world program in ArnoldC. This is it. So there's not a lot of intellectual ballast in this particular language, but it's more of an interesting tidbit. Then we have whenever. Whenever is a programming language that emulates a teenager that has a to-do list, but doesn't really care much about it. So lines in this program, in the whenever program, will be executed at some point, perhaps. The order in which they are run are not guaranteed. So what happens here is that you have your lines in your program, and at random these lines will be picked and run. They're all thrown into the stack, then picked at random, executed at random. It is possible to mark specific lines to be dependent on circumstances, that if these circumstances are not met, then the line will not be executed this time, but it will be put on the stack again. Since we don't really have any kind of real flow control, then it doesn't make much sense to have variables either, and data structures, nah. So a hello world program in whenever would be really simple because it's basically just one line. Fibonacci program is a bit more interesting. This will at some point eventually show the first 100 Fibonacci numbers. I'm not going to go much into details here, but you can see that much of the program execution is about hedging yourself from the lines being run at the wrong time, basically. Number 8, Shakespeare. So the goal of Shakespeare was, in the author's own word, to make a language with beautiful source code that resembled Shakespearean plays. It's designed about 15 years ago. So the special thing about this is that when you read a Shakespeare program, it's basically written like a play. If you just skim one of these programs, you could actually think there was a real play written by Shakespeare when he was drunk. So variables are declared at the beginning of the program as characters under dramatis personae. So you declare them the people who are about to be at the stage. And the play is split into acts, which again are split into scenes in order to have some kind of structure and to be able to have go-to statements between the various parts. And for the variables to be able to, or the characters to be able to do stuff, they must enter the stage, and they must also leave the stage again once the scene has ended. So, remember that the characters are the variables here. The characters utter the lines in order to either create an output or a statement, which in turn will make another character alter its intrinsic value. Now, there are a few different kinds of statements. A statement can be flattering, which will increase the value of the character being spoken to, or it can be an insult, which, on the other hand, will decrease the value of the character being spoken to. You can have conditional statements are done. These are done by having the characters raising questions to other characters. You can do output by using the sentences open your heart or speak your mind. So if we look at the Hello World example, the infamous Hello World program, we see that we have our personae dramatis up here, Romeo, Juliet, Ophelia, Hamlet. Those are 4 variables that enter the stage here. And then they begin insulting each other in order to decrease the values of each other, basically. Eventually, once in a while, we call speak your mind in order to output whatever we ended up here. So basically here we're trying to make an h by decrementing a value until we reach the h character, and we go on for a while. So this is a Hello World program of Shakespeare. Number 7, Velato. This is actually a Velato program because it uses MIDI files as source code. So programs are represented by the pitch and the ordering of notes, and they have a tendency apparently to have jazz-like harmonies. It was invented by this guy, Daniel Temkin, who has far too much time on his hands and have made a lot of other languages. For instance, this guy here, Entropy, where data increasingly becomes randomized the more it's accessed. So the more that you actually access, read a variable, the more it's randomized. Folders. The program is defined on the basis of a folder structure. That's it. Don't have any source code, just folders. And timeout, where every line is a timeout of so-and-so milliseconds. So you run a timeout continuously in JavaScript, and whatever instruction you reach when the timeout is ended will be whatever is executed. This is a bit reminiscent of whenever, obviously. So this guy here is our Hello World program. So I actually got YouTube up and running. So let's see if I can try and make it say something. And so it goes on. That's Hello World. All right. Then we have this guy here, Trump script. Yeah. So Trump script received some amount of hype, at least given that it's an esoteric language, which naturally does not generally have that much hype. Created by these guys very recently, I think about a year ago or something like that. Now, luckily for Trump script, Trump has prevailed and has become the presidential candidate against all odds. One can only hope that he ends up being president, if nothing else, than to keep the actuality of this language. So there are a bunch of principles of Trump script. Again, I'm just going to leave them here for you to peruse them. And there's more stuff. So basically, this is just a silly Python-based scripting language, which has a bunch of stupid rules, but designed to basically make a point here. This is Hello World in Trump script, where this looks a lot like ArnoldC actually. insofar that the message is more important here than the actual usability of the language. Most importantly, Trump doesn't like to talk about his failures. So a lot of the time, your code will fail, and will do so silently. Just think of debugging as a fun little game. All right. Most of the stuff that we've been looking at so far have been silly little languages that haven't really had much deep thought lodged into them. Now, the remaining languages, or some of them at least, are a bit more interesting to look at. Piet, for instance, is actually one of the more famous esoteric languages. It's kind of a visual version of Velato. It's written by the same guy who also wrote Whenever, and it's inspired by the paintings of abstract artist Piet. Any of you guys know him? Not really? Well, his paintings look pretty much like this. And your programs in Piet also look like that. It's a relatively popular language, if you could say something about that, an esoteric language. And it has its own IDE, actually. So you can draw your own programs in this IDE. This guy who made Piet also made a bunch of other languages. Chef programs look like cooking recipes. And another language called Ook, where all the instructions are, in fact, Ook. Now, Piet is interesting in many ways. The way it works is that it looks at the actual colors being used. Piet has up to 20 predefined colors. But the colors don't really matter that much. What matters is the shift in hue and lightness that happens during your program. So if we go back to this guy here, then a Piet program will always start up in this corner here, and then it will move to the right. And the colors that are under the pointer or the cursor as it goes along, or the shift in colors actually, are crucial in order to find out how that program works. So there's a direction pointer moving to the right. Now, and the command that's executed depends on the shift in hue and the shift in lightness or brightness. And then we have white and black blocks as well. If the interpreter hits a black block or an edge, falls out of the image, the direction pointer will switch directions in a 90 degrees clockwise fashion. So if we end up here, then we will shift and go this way instead. So these two tables here are crucial in order to understand how Piet actually works. So when you have a color change from one to another, then what you look at is A, did we get a change in hue? And two, did we get a change in lightness? So let's say that we were on a yellow block here, for instance, and we went to a dark blue block. What happens is that we shifted 1, 2, 3 hues, and we also shifted one point of lightness. We went one darker. So that means that if we start from here, look at this table here, we had 3 steps here, and we had 1 step darker. And what basically happens here is that Piet is one big state machine, pretty much, that moves from one state to another and just looks at whatever is it that I happened to fall upon here. Yeah, so eventually, Piet, the pointer just moves along, looking at the shifts in hue and lightness, and finding out using this table what to do, where to go, etc. If there is white color, then nothing happens. But once you get on another color instead, what happens is that that is not registered as a shift, meaning that you have a possibility, for instance, of going from yellow to dark green without having an actual change triggered down here. Oh, so these are programs written in Piet. These are all Hello World programs. They all do basically the same thing, which of course is interesting because this means that you can make highly visual, highly interesting programs that look in a variety of different ways, even though that they are basically doing the same. Again, if you were trying to build something meaningful in this, that would probably require a big canvas. Whitespace. So the name kind of gives it away. Whitespace programs only consist of tabs and spaces and new lines. Everything else is ignored. Now that is a pretty dull language in general. So why is this interesting? Why do you think that this is interesting enough to make it to this list? Well, the reason for that is that makes it possible to actually make two programs in one. Because some languages like Python, for instance, are very pesky about how you use your tabs and your spaces. But a language like JavaScript, for instance, or Java, often doesn't really care about that. So that means that you can actually write a program in, for instance, JavaScript or Java. And if you have interesting indentation, you may actually have an entirely different program in Whitespace all along. So this is seen once in a while in the hacking competition and so on, where people create hidden programs written in Whitespace while presenting another innocuous-looking program written in some other language instead. All right, any questions at this point? No? All right. This is how Hello World looks in Whitespace. All right. Next up is Befunge. Befunge is designed with the explicit purpose of creating a language that is as difficult to compile as possible. So they do this on two different levels, partly by working in 2 dimensions and partly by the code actually being able to modify itself as it goes along. For some reason, this language is somewhat popular and has spawned a number of derivatives called fungoids. And it's relatively old. It's from 1993. It's 23 years old. So this is what Hello World looks like. I'm going to briefly walk you through it. So what's interesting here are these guys here. Because, as I said, Befunge is able to work in 2 dimensions. So instead of a regular program that just goes line by line by line by line, and that's basically it, what happens here is that we move the pointer here, from here to here, from here to here, and here, and here, and we keep on doing that. So in this case, the colon will copy the top of the stack, and then the underscore will pop what we just copied, move to the left if there's a value, move to the right if there's not. Obviously, this will happen for 11 times in a row until there is nothing left in the stack, At which point, instead of us cycling back and forth here, we'll move over here, which incidentally is the instruction to exit the program. Does that make sense? If not, that's perfectly okay. It's it can be a bit tricky to to work with stuff like this. And there's this guy. That is Brainfuck, or Brain F something CK, it's often called. It's probably one of the best known esoteric programming languages ever. So when I walked in here and some guy asked me, what are you talking about? Talking about these esoteric languages. Oh, like Brainfuck. So this is something that some people have heard about at least. And it also has an interesting history because this guy here was built many years ago, also in '93, like Befunge. And the main purpose here was to create a language where it's possible to write the smallest possible compiler for Amiga OS 2.0. Now, for those of you who may have had an Amiga back in the early 90s, you probably know that there was a thriving demo scene at that point, where people were actively contesting about who could ride the most juice out of these relatively limited machines that were available at that point. So obviously, this was one of the means to do that. It only uses 8 symbols. Everything else is considered a comment. And the symbols are used to jump back and forth between memory cells and read from them and write to them. And how many of you guys know about Turing machines? Yeah, quite a few. Good. Basically, if you look at the way Brainfuck works, it pretty much just emulates a Turing machine. So it's really basic, but it does the job. There's also a derivative language called smallfuck. It only has 5 symbols, so even more concise. And accordingly, does not define input or output, meaning that you have to have that ready on hand already. It only operates in bits, where Brainfuck instead operates on memory cells containing bytes. So smallfuck is even more hardcore than Brainfuck is. The symbols that we have available are these, where you move the pointer to the right and to the left, increment this memory cell or decrement it. This is all you need to make a functional Turing. And that is what this program provides you. A Brainfuck program is simple in nature, but it's not always simple to deduce when you look at the code, because the code looks like this. All right. So the final language I'm going to talk about is called Malbolge. This is a picture showing a scene from Dante's Divine Comedy, more specifically from part of the book that goes on in hell, called Inferno. This specific language is named after the 8th circle of Dante's hell, Inferno. It's called Malbolge. And it's designed with the explicit purpose to be practically impossible to use. There are some design flaws in the language, though, which eventually had the unfortunate result that people were able to make programs in this language. It's possible, though extremely difficult. It took 2 years from Ben Olmsted, the author, introduced the language until someone actually wrote a program in it. But truth be told, actually it wasn't written like that because it was generated by another program trying to brute force a way to build a Malbolge program. This is how dedicated these guys are, apparently. 7 years after 98, when it was introduced, the first correct 99 bottles of beer in the wall program was made. And there's also a derivative language called this, which is a so-called WIMP mode version of it, which is explicitly designed to walk the line between humanly impossible to program and just extremely painful. But of course, purists use the real deal. So invented in 98 by this guy who has not once written a program in Malbolge. He was the guy who made this as well, by the way. So understanding Malbolge is a very daunting task. I tried spending some time doing it, and I do not recommend anyone trying to go down that path, to be honest. The thing about Malbolge is it actually has a virtual machine. Most of the stuff that we've seen so far, the languages have been relatively simple. Malbolge is, of course, designed to not be simple, so it has a virtual machine to complicate things further. It's not based in bits, it's based in trits instead. So instead of just having 0 and 1, we add a 2 as well, just because why not? Fun fact, back in the 60s and 70s in the USSR and General Eastern Bloc, the computers made there were also based on trits instead of. Why change a winning formula? That virtual machine has 3 registers: A, the accumulator, used for write operations and I/O; C, code pointer, pointing to the current operation; and D, the data pointer, containing data from memory. Virtual machine has 3 to the power of 10th memory locations, and each of these can contain a 10-digit ternary number. Overflow will just start all over again. Now, the thing about this memory limit, that means that unlike most of the other languages we've seen, Malbolge is actually not considered Turing complete, meaning that it cannot fully emulate a Turing machine. And the reason for that is that a Turing machine should, in theory, it is a theoretical concept, it should be able to work indefinitely, and that's impossible since the virtual machine here has a hard limit on the memory that it can consume. Now, when we execute a program, we feed, of course, the program instructions. If it is not in the range 33 to 126, then the program is just terminated. Unless you use reference implementation, which just hangs because, well, yes. Otherwise, the value that C is pointing at will be added to C itself, and this will then be divided by 94. The remainder will determine which instruction to run, which could be output the character saved in A, modulo 256 to stand it out, set D to the value D is pointing at, tritwise rotation, no up, just nothing, or what we call the crazy operation. So the crazy operation is a tritwise operation that sets A and whatever D is pointing to 0, 1, and 2 based on this truth table here. No reason why, just, yeah, why not? After each instruction, the memory position the C points at is inspected. If it's within the range of 33 to 126, it is encrypted based on the following table. Then both C and D are incremented with modulo 3 to the power of 10. Does that make sense? So this is Hello World Malbolge. All right. To wrap it up, I hope you enjoyed it. So the point of this, of course, was to show that there are a lot of really silly languages out there. Some of them just made for jokes. Some of them even made for April Fools that only work on one specific day and then they don't work anymore. But there are also languages that are using very unorthodox ways to solve problems that normal languages often have a harder time doing, which was the case of Brainfuck, for instance, which was actually written as with a specific purpose in mind, and the purpose was not to be annoying like some of the other languages here are. Yes, now obviously I haven't been actually programming in many of these languages, but if you have questions, I would very much like to hear them. Yes?
Is there a Hillary script as well, and does it have a fate instruction?
All right, I'm going to have to check the archives for that one.
Okay.
Take a look at esolangs. I wouldn't be surprised if it exists.
Okay.
Anyone else? Yes?
Some of the more known old ones, are they still maintained, or are they just lying there?
Well, if you look at Brainfuck, for instance, Brainfuck is kind of pretty self-contained language. It's hard to make it better, so to speak, because it's very concise. But usually the languages themselves are not maintained that much, but a lot of derivatives are made. For instance, Brainfuck, you had the smallfuck version, which is newer and tries to work with what Brainfuck does, but in a different domain. Befunge, as we saw, had a myriad of different versions of that because a lot of people thought that this whole two-dimensional thing was very interesting. Let's try and work on that and see what we can do about this. But I think most of the languages are not that actually actively maintained. Piet maybe, but most of the other ones probably aren't. Yes?
Has anybody tried to make a movie that is that will compile in ArnoldC?
I haven't heard of one, but I hope that would be the case. All right, I think that wraps it up. By the way, thanks for your time.